Hi and welcome back to the lab. And today here on the bench we have a Yaesu FT-991A. And the radio has problems with switching the PA, or better say it doesn't switch any longer. So the connected power amplifier is permanently on transmit. So that very often happens when you connect an older PA to a modern radio without having a circuit in between. If you don't know what I'm talking about, simply watch my video 208 where we describe the problem and showing up a solution. But here it is a little bit different because the operator is using such an adapter which is in between to really protect the radio for an older high voltage PA, right? So the problem must be a little bit different, because even the operator would use an older power amplifier with using this PTT relay, it is called, it should not happen. So let's have a look. So that could be an interesting one. Okay, and here is our radio, FT-991A, and without having a power amplifier connected, you would not recognize that something is wrong. So let me show you a little bit why and where we can find the problem. And of course the operator is using a power amplifier, and that is why he directly recognized it, because as I already said, so there was no way to get the PA back to receive. It was always on transmit. And of course here at the back side we find this connector, which is for an external tuner and for your linear amplifier. And as I already said, so this adapter was connected here to the radio, right? And on the other side, or here in between, this is this connector called PTT relay, which is doing the converting, if you like. And then you have here your cinch connector, which are connected to PTT, and the other one is here our ALC, which gets connected to the radio as well. And well, so now what we can do is our first check, and that is simply connecting here our bench multimeter to our connector, and well, so we can test for continuity. So our radio is of course set to receive, so no PTT is pressed, and now, and you already hear that we have continuity here. And let's investigate that a little bit more. So once again, I test here for continuity, and what we see is let's say 4 ohm, and well, that is clear. So we have a kind of saturation voltage at our switching transistor inside the radio, but have a look how it works. Okay, so that is the main board, very confusing, and we have down here our connectors, but let's zoom in. And that here is definitely a better view of what we are interested in. And have a look, here is our connector, and here we see a tuner or linear, and that is our pin 2. And now let's simply follow where pin 2 is going to, and we are ending up here at our Q1145. Our Q1145 is simply a switching transistor to ground, okay? So that means if we now following here our baseline of this NPN transistor, we simply go up and follow the line, and hopefully I really see where we are going to, and maybe I've already lost it. No, I have not. So you see it is here. Let me go over and let me zoom it in a little bit more, and you see it is TX9. So that is the TX9 bus, and that is when you switch your PTT. Then the radio is switching over to transmit, and the radio is producing its TX9 voltage. And coming back here to our switching transistor, since that is an NPN transistor and we get a positive voltage from our TX9 bus here to the base, yes, this transistor is simply switching to ground. And that is of course exactly what we want when we press PTT and we have a power amplifier connected to the radio. We want to set our PTT line here over our connector to ground, because that is way how we switch our power amplifier, which is connected to the radio, to transmit. And that is a little bit more in depth explained in video 208. So there you can get some more information on that. Okay, but here in this case, our adapter, and we have here, let's say it is switched to ground. Right, but one could say, okay, it might be here our relay, PA-PTT relay in between, which is making trouble. And you're right, that really could be the fact. So therefore, we really need to look here into this port and see what happens when we, really have here our multimeter connected to, and see what's really happening then. Okay, as you can see, we have taken off our PTT relay, and what I've done, I have put here a little wire inside our connector in order to be able to test. And you see that we have here connected ground from our multimeter, and now let's see what we have. Oh, so we have here, as you can hear, continuity, and that is definitely wrong. So let's go back to our meter and let's check it again. And that is me. Yeah, now I have it. Come on here. And you see, we have somewhat 14.5 ohm, and you see that is higher what we have seen at the output of our PTT relay. And of course, maybe 14.5 ohm is, let me call it in brackets, enough ground to let our PTT relay switching, and that is why we see 8 ohm. So obviously our PTT relay is working right, but something is very weird in our radio. Okay, so now we can see both our power meter and our ohm meter, and let me try to connect here our continuity test to the radio. And again, so we have here our 14 ohm, and now I just wanted to know what happens when we press our PTT. Aha! So you see that our radio is transmitting while I'm talking, so that is in SSB, so that is right. But what you can see as well, that when we press PTT, that our resistor gets reduced. And that, you know, so let me switch it off here. So that is really weird, because we see that the transistor itself is switching, but without having pressed the PTT, we see finally, or not finally, so we see 14 ohm, which seems to be low enough to get our PTT relay in between here engaged. And so something is wrong in the radio, and now we have collected a lot of information that we really can crack open the radio and see what's going on. Okay, so radio is cracked open, and now let's zoom in. And without looking into our service manual, so what we can see here, and I believe that what we see down here, so that here is our little switching transistor. And what you see as well, that you see somebody was working here on the radio. And so I heard from the operator that he had the radio in the shop, in another workshop, where they performed a warranty job. I don't know what they have done, but by the look of it, I presume that they already worked here on this transistor. I mean, okay, I have to verify if that is really the transistor we are interested in, but I'm sure that it is. And it looks like that for what reason ever there is glue here in place, and that is definitely nothing what you would find from the factory. So first I will confirm that this is really the transistor we are looking for, and secondly, what has happened here? So why is it glued? And yeah, okay, so let's try to find out. Okay, and sure enough here, that is a transistor which is glued, our Q1145, and that is exactly what we were looking for. And that means that, of course, somebody already works on this transistor. And look here to this little component, which is an F. So that means it is a fuse component, fuse, yeah, a little fuse, SMD fuse. And let's have a look into the circuit. And look here, so that here was the little ship fuse, and that is now a wire. So that is professional, isn't it? Unbelievable. Okay, to be fair, so it is not a little wire which is in, so they put here, I'm not entirely sure what component is used, but originally it should be a little ferrite, which is here in line. And yeah, ferrites of this size very often gets used, of course, as a kind of little resistor, fuse, whatever, that something protects if there is a short or what have we. And so that is, you know, a little SMD part put in vertically. So yeah, okay, might be okay, as the workshop it didn't have, you know, something which fits size wise. So yeah, okay, so that might be okay. But anyways, now we have really to get all this glue off what we have here, to get really here to the components, because we have two resistors down here, and of course the transistor itself, and very important here this diode, which is a kind of dumper diode. And yeah, let's try that we get all the glue off. So okay, I have put it now under the microscope, because we need to avoid to damage here something, if that is possible. So I've already tried here to pull a little bit of the glue off, but as you can see, not everything. So I really try my very best not to damage here something. And yup, so we have it off. And well, now what do we have here? So we have here obviously two new components, obviously, which are size-wise too great, and you know, yeah, you should not really do that. From this view, it looks like diodes, but I'm not sure. I'm also not sure if you know, this transistor has already been swapped out. I cannot really say what has happened here. So the only thing I can do is try to get it clean as much as possible, and then try to get away here. I don't know. I really don't know what this is, or for what. I definitely have no idea. Anyway, so let's try to clean it a little bit up, and let's try to understand here a little bit better what has been done here, and then we definitely can decide how to proceed. Well, by the way, I would never put something under glue, so that seems to be a normal household glue or something like that. So, you know, it is always better to put, I mean, you have situations where you need to cover a situation on the board where you have repaired something or modified, so for sure, no question, but you should do it with hot glue, which can be removed easily with some alcohol, and that is a good insulation. So I do not know how this glue, how resistive it is, for instance, so that, you know, the glue with the age becomes a problem or what, I don't know, but it is definitely not a good idea to use this normal household glue, which I believe it is. So if you ever need to do or if you ever need to cover something on a PCB, which is normal from time to time, so use hot glue, which is much more professional as what we have here. Okay, it is not completely clean, but yeah, we need to probe here a little bit, because I still do not really know why this has been done. I mean, what we need to probe is the voltage here at the input. So down here, that of course is our base down here, right? And so that means at the input of our resistors, what I still believe this modifications is, not 100% sure. Maybe there is also a diode involved. We will see it later. But anyways, we should see when we probe down here on receive no volt, and when we press PTT we should see our TX9. So that is easy to understand. And what we need to have, we need here at our base, of course, when we have receive a condition, we should see nothing, no volt at all. And we should see, on the other hand, when we transmit, we should see, let's say, something around 1 volt, even lower, because saturation voltage base emitter is most likely below 1 volt. So that is what we should see, that our circuit can work properly. So again, what we check are 2 conditions. First of all, here our input of the resistor, and then we want to see what we have on base. So let's change over to our meter. Okay, so here's our meter, and as you can hear, our radio is switched on, and it is of course on receive. So now I'm going down to where we should have no voltage at all on receive. Let me go down there to probe it. 1.7, almost 1.8, which is, so that is definitely wrong. Remember, we are on receive. And now let me check the base voltage here. And the base voltage, yeah, okay, so the base voltage is already almost 600 millivolt, which would explain that we tested, what was it, 13 point something already when the radio is switched on, and that is also the condition that that is obviously enough to switch our PTT relay. So that already is wrong. Anyway, so let me go back here to the, where is my input? Here. So that is the input where I would expect my 9 volt PTT. So let's switch over to transmit, and 8.8. So that is definitely right. So that is our transmit TX voltage. But when I go back to receive, we should not see 1.7 volt. So there is definitely something wrong. And let me go back to the base. So that is receive. And now when we switch it, when we press PTT, and yes, so we see almost 700 millivolt, which makes sense to saturate the transistor, because we want to put our output, so the collector of our transistor, to ground. So that definitely makes sense, right? But it is not right that we have already almost 600 millivolt on receive. So that is definitely wrong. But before we now start to troubleshoot why we have here already 1.7 volt, I really would like to remove this modification, and let's then test again to see what the changes are. Okay, sure enough that we take all components off which have been added here. Okay, so let's first take out here our whatever it is to get here a better impression, and then we can really decide how finally to go ahead. Okay, so let's see, now I have the right temperature to do it. Okay, there we have it out, and maybe that the temperature itself may also help a little bit to get off the rest here of our glue. Let's see. Okay, and here we can see what the guy, whoever that was, but it must have been a Yaesu certified service center, because otherwise they wouldn't be able to do warranty repairs. But anyway, so that is what he did in. So that is a diode, a normal diode voltage drop of 0.7 volt, and in line with come on, in line with a 1K resistor. So what the guy tried is to drop at minimum 0.7 volt here at the diode in order to get the voltage a little bit more down. So that means that he recognized the problem somehow, but obviously he was not able to analyze it in the right way. So I do not know if this 1.7 volt what we have seen in RX, I'm not sure if that was there before. So maybe that this developed over time, and now where we have this 1.7 volt on receive, that was already enough to switch here our transistor. So you know, that is not entirely clear what really has happened, but anyways, yeah, that is not the best construction what we have seen here. So cross fingers now, but we'll try to really gentle get it clean. Let's see what we can do. Come on. I don't want to press too much, right? Because otherwise, yeah, looks good, looks good. Very nice, looks good. Now, let's be very, very carefully cleaning it. And then we try to fit in the new resistor, of course. Okido, very nice, very, very nice. So that is good. And of course we have a brand new 10K resistor as well, which we put in now. Our 2K resistor is already in. Again, I hope that we do not damage something, because still this junction here is not 100%, but yeah, hope. hope that it works out. Okay, so let's try. The frame is in the way a little bit here from the radio. Frame. Alright. That is already good. And the only thing left is to clean it here a little bit. And then our 10K resistor is in. And that is what we need, but I have to clean it a little bit more, as I can clearly see it here. No problem. Okay, so that is now the situation after cleaning and after replacing the modification. So everything is now back to normal, and now we really need to find the problem. Because what we have seen here, and what obviously the repair shop did before, is trying to cure the symptom, right? The symptom, but not the root cause. I mean, putting a diode here in between to reduce this 1.7 voltage a little bit, yeah, that is a poor idea, because something is definitely wrong with this 1.7 volt, and that is really the root cause of the problem. So what we need to find is why we get 1.7 volt is maybe somewhere in the TX RX switching, because we have to switch between RX voltage and TX voltage. And is there something wrong that there is a rest of let's say 1.7 volt, or is a component leaking or such? So that is the real reason why here our switching is not working. It is not because the components are wrong or the transistor is broken or whatever. That is not the problem. So now we really have to go and look for the root cause. Having said that, we have to look a little bit more here in our RX and TX switching. So that is what I already said. And down here we have our both transistors. So both transistors are here. So that here is the RX supply, and that here is the TX supply. So that is switching when you press your PTT, right? So therefore here we start searching for our problem. So normally this area is covered by this little PCB, so that is sitting above, so the radio will not work in the moment, but we can switch it on and we hear static, so that is enough, and we can press PTT and our circuit here is switching. So therefore we can investigate here this situation. And that you know what I'm talking about, and that you follow when I start probing. Here we have our little situation, and yeah, maybe we zoom in a little bit more, that it is a bit more and easier to see. So we have here this both medium power transistors, which is this one and this one. So, and you can see here that is our TX9, so we already know that. And that guy here is our receive voltage. So very simple, very simple. Then we get Tx, and that is what we read down here. And that means if we have triggered our PTT, then we get a positive voltage here to our NPN transistor, this one here, okay, here positive voltage, and this guy will switch to ground. And then that means that this transistor gets switched through, and our TX9 will be present at the collector, right? And when we release our PTT, then of course it goes back into idle, and that means we do not have our TX voltage. But then we of course have our RX voltage, and that is what will get switched here. So you see this little digital transistor is switched by, so we have here a 9-volt bus, and that goes over our 4.7K resistor, goes here to the base, and this base then will switch this transistor through that we have our RX voltage. And when we get here our PTT, then you see this little digital transistor which will pull down our positive voltage from the base, so that this medium power transistor stops working, and in the same at the same time we will get our TX9 volt switched through. So that is how it works, and we now want to check the conditions here at our transistors to understand if we may have a problem here in this switching. And therefore, of course, we go down here, we probe around and try to understand what's really going on. And it's good to have both the same transistors, because more or less the voltages needs to be a little bit identical, because it is always the same. It is not important which one is switched through. Both transistors should work in the same manner, and so we can compare a little bit the voltages between these both transistors. Okay, so let's probe a little bit and hope that we all can see what I'm doing here. So first of all, our TX transistor, which is this one, and what we can see at the collector is our known 1.7 volt, which is wrong. Now in comparison, we look at the collector of our RX transistor, which is now engaged, and here is it, and we see we have our 8.7 volt, which we would expect. And now the first test what we can do, so we stay here on our RX transistor, and let's go and press PTT, and you see that the voltage at our collector is collapsing to almost zero. Okay, and that is exactly the behavior we would expect from our second or TX transistor. So we have here again our 1.72 volt, which we know. And now again, when we go on transmit, so you see we have here our TX voltage, which is right. Now I release PTT and we would expect to see 0. And still the question is, why do we have here a rest of 1.7 volt? And when we go here to our base voltage, so we see, so it is not engaged. So we are on receive, but we are probing at our TX transistor, and we see at the base 8.8 volt. Now we go over to emitter and we see 8.8 volt. So that means we do not have a voltage difference between emitter and base, and that means that our collector should be completely switched off and we shouldn't see nothing. And that is what we see here. Once again, back to our receive transistor, and now that is our output voltage. Now we go to transmit, because now it is collapsing. And now let's see here the same situation. That is our emitter voltage, 8.8 volt, and now our base voltage, which is 8.8 volt. So we do not have here the needed voltage difference to switch it through. When I now release here my PTT, you see now at the base we have approximately 8 volt, and at our emitter we have still our 8.8 volt. So that means we have approximately our delta of 0.7 volt, which is needed to switch the transistor through, and that is the result at our collector. And we have a completely different behavior of our transmit transistor, where we still have 1.7 volt. Also, we do not have a voltage difference between base and emitter, and that means that we should not see our 1.7 volt, and that could mean that the transistor itself may have leakage, or there is another component here on the board which do feed voltage to the collector over the whole circuitry here, because there might be another component which is leaking somewhere. But that is a matter what we only can evaluate when we take the transistor out, and that means we can test first the transistor itself, and secondly we can test if the 1.7 volt is still there, even that the transistor is out. And that would mean that we have another component here on the board which is leaking, and that then becomes very, very exciting to find. Well, we have here a delicate situation on board in this area, since we have here these plastic posts, and therefore we really have to be carefully not to damage anything here. So I hope I have covered everything in a good manner, so that we can get here all component out to be able to test further. Okay, and as you can see, we have taken out here our TX transistor, and now I'm really curious to test the transistor, whereby I do not really believe that it is the transistor, because it is very seldom that we have leakage on a modern silicon transistor, so that more often still happens on germanium transistors. So I don't believe that it is a transistor, but anyways, we need to evaluate it and to then plan how to go ahead. Okay, so I have my transistor tester already prepared. So let me simply hook here my transistor to the tester. Okay. Now that's fine. And now, yeah, you haven't seen it. Sorry for the bad camera operation here. So it is connected here to my tester, and now let's test it. Okay, so ready for testing. Let's go over and test the component, and it's analyzing, and here we have already the result, and it is a PNP, that's right. HFE, fine. And what we are interested in is there a leakage? No, and obviously our transistor is fine from the first look. So very important. No, it's don't know if you can see it, but you can see over there, sorry, that there is no leakage, and we have obviously a good working PNP transistor, which was expected. But anyways, let's write its graph, because sometimes that will tell us a little bit more. So let's test our collector current versus voltage collector emitter. And you see we test now with different base current, and you see the graph which it's building up here looks quite good. So that's the first what I really wanted to make sure, so no problem whatsoever. But let me test HFE, which is our gain versus voltage CE, and that is interesting to see, because then we see if the gain of the transistor is always with all different base current the same, and that is what we expect. So we see it is approximately 220/30, and you see already the second test with lower current, so base current, so that's the right thing, and you see they all writing over each other, and you see the third one as well. Now the fourth is running, and you see they are very, very identical, and that is exactly what we want to know, because when we would see that with different base current and of course different collector emitter voltage, we would see a different gain, which HFE is, then there would be certainly something wrong. But you see, test has now finished with 5 different gate currents, and you can easily see that they all match over each other, and that means that independent the gate, the base current, we have the same gain, and that is then more or less a proof that our transistor is really working fine without any problems. And we have seen here our voltage collector emitter versus collector current, and you here can see the well-known diagram. so everything seems to be fine. So that means that most likely our voltage, our 1.7 volt, comes from somewhere else. That now means that we have to remove all here our tape in order to do not have any shorts here, of course. So we take everything off, and then we can test and we can see if we still have here our 1.7 volt or if it is gone. But if it is gone, that is then weird as well. Anyways, so let's go the next step. Okay, so as you can see, we have removed all the tape so that we really can go ahead with testing. And so far our expectation was that when the transistor is out, we still should see that here our 1.7 volt is present, because we have seen that the transistor itself is fine. So that means the 1.7 volt must still be here, because we think and we expect that that is a leaking voltage from somewhere here on the board, and that is something we want to check, because as I already said, if this 1.7 volt is not present, then it really becomes weird. Okay, anyway, so radio is in receive, and let me go first here to our receive transistor, and you see, I hope you can see it, we have 8.7 volt, so that is confirming the RX voltage is there. Our transistor is out, and let's see what we have here. And that is exactly what I thought. So we still have our 1.7 volt, and that definitely means there must be somewhere on our PCB a leaking component, which gives, you know, most of the time it is that, you know, our receive voltage, our RX voltage, is of course distributed all over the board, and of course we have somewhere on the board connections where RX voltage and TX voltage, depending on what we are doing, receiving or transmitting, is present. And that means there are components in between which needs to avoid that an RX voltage is going into the TX path, and the other way around, no TX voltage is allowed to go over into the RX path. So therefore there must be one component which is doing something funny. So let's think us about what we can do as next step. So our Q1061 is out, and still here on the pad, on the PCB pad, on the collector, still has its 1.7 volt. Okay, so that means we really need to follow the RX line. So first, I mean, you see it is going here to the right side. On the other hand, it's going to the left side. So let's follow a little bit where it is going to. And I just following here our, I should not lose it. I'm just following here our TX line, and we are coming over to a to a diode, and let's see, let me zoom in here a little bit more. So we are coming to this diode here, the D1094, and we have here filters which are responsible for different frequency, as you can see, and these filters get switched obviously for TX and RX, and here is our RX TX D1094, which would deliver this would deliver to this circuit our 9 volt TX voltage. And on the other hand, if we follow here along, yeah, so we see here we have our R9, right? So on receive we get over this transistor here our RX voltage, which is as well 9 volt, over to exactly the same point. So we are not really interested here in the circuitry. What we are interested in is the question if when we get our RX voltage over 1093 to the circuitry, then this 1093 delivers its voltage also to the cathode of our 1094. And consider if the 1094 is leaking, then we would see a bit of this, let me say, it might be around 5 volt, I don't know. There are some resistors in between here and there, and what have we. So let's assume we have a 10, if we have 5 volt, so this 5 volt would be here as well, and if the 1094 is leaking, then we would see, of course, on the other side a voltage, maybe our 1.7, but the problem is we have many connections. So I've just seen on the other side, I mean, okay, let us go back here where we find our distribution point. So our distribution point is here, right? So here's our transistor, which no, not that one. Here's our TX, and the distribution point is here. And when we go ahead here, so we get up here, and when we go up a little bit more, we get, I've missed the pass, sorry, here's the pass, we get here to the 1091, and the 1091 also is connected to the 1092, and the 1092, look here, is getting provided with RX voltage as well. So it could be this diode as well which is leaking. And I'm sure that there are some more points here on the board where you know, our RX voltage gets in contact with our TX path, and that is what we have here. So here we have a direct connection on the RX and the TX path, and it is only blocked by diodes. Alright, so let's go into our circuit and let's check if maybe these diodes are leaking. And I've already looked a little bit around here on the PCB plan, and what we can see here, so here is our D1094, which we have seen, And what we need to do right now is to check if we may have here a leaking 1094, and the other diode which we are looking for is here our D1092, and that is the second point where we check if maybe there is something leaking. And yeah, therefore let's go into the circuit and let's check what the voltage are. Okay, I guess so we can see both, and I hope I can get down to the test point, which is now a little bit difficult, but let's try if it is possible. Okay, so that is the cathode of our diode, and you see that is a fraction of our Rx voltage, and that is fine. And when I now go to the other side of our diode, I am getting what? It's a little bit difficult. And look, so on the other side we have 1.72, and that is exactly what we have here at our transistor tap, 1.72. And to be honest, since we are reading here as well 1.72, so we do not have a kind of voltage drop between our transistor tap and this diode, I do not really believe that this diode is leaking, because we should see a little bit higher voltage down or up there. And now let us go to the other side of the filter, as we have seen it on our schematic. And let me try to probe the cathode side of, what is it, the D1091. Let me try to go down to that diode. And okay, 4.4. So again, that is a fraction of our Rx voltage. Reduced by all the components which are in between. And on the other side, let's see what we have there. And again, our 1.72. And again, I don't believe that that is a leaking component, because we should see a higher voltage. And that is, on the other hand, the advantage if you have a multimeter with a higher resolution, because you can exactly see even little voltage differences, and so that really helps if you have a problem like this, where it really every digit counts. Okay, so that means we were not successful on this diode, and we was not successful on this diode, so we really need to go ahead. And when we now go into the other direction, we will find some circuitry where we have a similar condition as well. And look here, we have here a similar condition. So we have here our Rx input on our PCB, and we have here the attenuation, we have here relay and components and whatnot. And what we find here as well is our, let's see, D1113. And the D1113 here is also directly in contact with our Rx voltage. So that is our transistor which already was supplying here our filter, where we have tested before. Okay, and this voltage here is in a very direct contact with the D1113, which is also connected to our TX 9 volt bus line. So let's probe here our D1113 and let's see what's going on there. Okay, and I found here on the board, very close to the relay, this little diode. And let me first test on the cathode side. And cathode is here. Okay, 3.4. So that is a little bit lower than what we have seen on the other diodes, where we had a bit over 4 volt. So that already looks a little bit reduced. But let me look on the other side on this. So that is the RX voltage. Let me look on the anode of the RX supply line, and that is 4.2, and so that is what we have seen on our other pass on the cathode and not on the anode, so that looks a little bit reduced. Anyway, so our D1113, so let us have a look on the anode, where we should see our 1.7, because that is our leaking voltage. Okay, let me go down. Okay, so look here. So we have not 1.7, we have 2.4. And that is what I've told you. Normally we would expect a higher voltage at the leaking component. And we read here 2.4, and on all the other points on the board we have seen 1.7. And that could be really our leaking component. Okay, let's have a look again into our schematic and let's think. Okay, so once again, so we have tested here. So that here is of course our supply pass for RX. All right, so we have here our transistor, and we have seen here 4.2, which I think is a little bit too low. And then suddenly we have here seen 3. I don't know, and here suddenly 2.4, and that is weird, because if this is not the component which is leaking or potentially leaking, then we should see here something 1.7, because that is widely distributed on the board. But we see here 2.4, and the next step is, let me go back. So you see we have here 220 ohm resistor, we have here 100 microhenry coil, and we have here another 4.7 ohm resistor. So let's go back and let's see if we somewhere find our known 1.7 volt. So that will be exactly what we are doing now. Okay, so now let's test exactly what we said. I mean, that is not very easy, because it's difficult for me to reach here the test points, but I try my very best without being too much in the way. So let me probe here. That is our diode. So that is the anode, 2.4. Now the next in the path is a 220 ohm resistor. Let me see how I can test. how I can test that one. So again, that is one side, 2.4. Now the other side, 1.8. Have a look. Now we get to our little coil. So that is input 1.8, what we have seen before. Now the other side of the coil, 1.84. And now we are getting to a little 47 ohm resistor, which is of course on one side again our 1.84, and now on the other side, let me check there. Have a look, 1.72 volt, and that is exactly what we find distributed on the board. And that means we really have to take off the little diode, because we have a good chance that this little diode is really leaking, and that is a part what we are looking for. So let us take the little diode out. Okay, so I've taken the little diode out, and you see it down here. So that is a very tiny component. So in relation to our transistor, which is out, that is the one I've taken out. And now next step is we test if we still have our 1.7 volt at our transistor pad. So that is now very, very interesting. Okay, I'm really excited now. So everything is prepared. First of all, we are testing our RX voltage as at the transistor, which is still in circuit. And yes, we have our 8.7 volt RX. And now we are going over to the TX pad, where we have the missing transistor, where we had our 1.7 volt. Do we still have our 1.7 volt? Let's go to the pad. Wow! Have a look. There is nothing anymore. So that definitely means that is the leaking component we were looking for. So our 1.7 volt is gone, and that is what we want. Great. So look here, I was able to test this little diode with my component tester, and the outcome is kind of funny. So it is identified as Zener diode, and that means we have in reverse direction we have 1.4 volt voltage drop, and in normal direction we have 0.7, which would be normal. But in reverse we should not see a voltage drop, and that is the proof that this little diode is toasted. So test is here on the little board. You really need to press this little diode down, and then of course you can identify it, and yeah, so that is what it is. Okay, and our toasted diode, so the D1113 is a RN142, and that is, here is RN142, and you see that is a pin diode, and that makes sense, but it is not a Zener diode. And so it is definitely proved that this diode is toasted. Alright, and that here is the situation on board. So what we can see is here is the diode which I've taken out is toasted, and we have here our other Bose diodes where we tested, so the D1090 and the D1089, which is this one, and we have to fit in a new one, so the 1113. So let's go and see what I have on stock. Okay, so I have a replacement type here on stock, so I need to take it out, and yeah, then let's see that we get it fitted in. Oh no, it is not fitting. So electrical wise it would work, but as you can see it is too small, so I cannot get it here in place because this little diode has no leads, and yeah, okay, so I really have to look out for another solution. Here you can see it, so no leads, and this guy is definitely too tiny, and I mean the other one is already so tiny, and that one is even more tiny. Okay, so let's see what I have as well. Okay, and the next diode which I have on stock is a little bit too large. So as you can see, yeah, I would get it in, but no, I don't like it. It is such a new radio. I mean, it would work this way, but no, we don't do it. I order the original one. Alright, so the needed pin diode has been arrived. So here is our RN142. And now we can complete this work here. Okay, so we have here our situation on the board, and you have seen the other components which I have tested here down on the pads, and we have seen that those diodes was or did not really fit, too big or too small. However, this one here is the original type. So as we have seen it in our manual, it is a RN142, but it is a other variant. So you see that size-wise it is a little bit smaller than what we have seen before, or what we see over here. So both are exactly the same types. I try to regulate the light here a little bit to get a better contrast, but you see that the newer variant is also a little bit smaller, tinier or whatever, but maybe you can see the marking is K as well, but size-wise you see what it means, and that is not only the RN142S, which is one we have here in our list on the service manual. So that is the RN142SM2R. SMT. Oh, it is SMT2R. That is a little side story on what we are doing here. So it is always changing, but anyways, you see it perfectly fits. Okay, as always, let's start here with a little flux to our first joint, and let's tuck it down a little bit that we can get it in place as we need it. Okay, so let's see. Okay, so that is already pretty good. So we add some additional flux, and then we can already finalize what we are doing here. Okay, let's go ahead. Very important to have always a clean tip here. In order to get a good flow down on the pads. Okay, looks quite good. And as always, of course, we have to clean it, and then we can already test its function, and let's see how it works. So, and of course, notice that we have here again an orientation, so don't mix it up. I definitely need to tell you that it then wouldn't work. Okay, so then let's test the circuit. Okay, so a last view here on the board, and you see it is extremely tiny. So there we have our component. Okay, and how can we test now? So remember, we had here at our switching transistor, we had a voltage which should not be present, because that was the problem why our PA switch was already engaged while the radio was on RX, right? So what we can test is if we have in RX still voltage, first of all, and secondly, we can of course test if our TX voltage will be present, and then when we release PTT, if still we have no voltage on RX. Right, so our radio is switched in, so you hear the static. I now go down here to the test point at our switching transistor, which is here, and you see we do not have voltage, which is right. Remember, we had there a voltage before. Now we take here our PTT on our microphone, and we press PTT, and that is our TX voltage which we need. And now when I release, we will see it falling back to almost nothing, and that is how it should look like. What can we test else? So I've put in here our little wire to make the contact, and I've connected here our ohm meter, and let's see if we have really a low resistance while we press PTT, and we have a high resistance while it is on RX. Okay, so what you see is that we have so it is 20 mega ohm, let's say 20 mega ohm, and now when I press PTT, it is going down to 1.5 ohm, and that is exactly the behavior we need, because Now it can really switch a relay down to ground in order to bring our power amplifier into transmit. Okay, and what can we test else? Remember when we started repairing this radio, we tested this Euro frequency thing here, which is called PTT relay for PR. For PR switching or whatever. So from Euro frequency, and we have seen that even on RX, where the radio is now connected to, so you see we have here connected our cable to the radio, and we have here on this end our cinch connector, which is now loose again. Okay. My clips might be a little bit too small for that, but anyways, what you see is that here at the cinch we have an overflow condition, which is good. Remember, when we first tested it, it was already switched and we saw a very low resistor. Now it is as we would expect it, and when we now press PTT, see, we have only 4 ohm, and that is exactly what we need. So the system is now working absolutely fine, so no problems whatsoever. But notice, it is not really necessary to have this wire for this radio and in between. So the operator is using a power amplifier which has only a relay in his power amplifier, which is delivering approximately 1670 volts to our transceiver, right? So that can be easily handled here by our little switching transistor. We have seen that that is an 160 volt type. So even a very old power amplifier should be able to get directly connected to your radio. But in order to save your radio, because you are not really sure what the conditions are and you don't really trust them all, so you simply can use something like this, because this PTT relay, this power amplifier adapter is doing the job for radios which are not able to handle such a high voltage coming from your power amplifier. But in this case we have this 160 volt transistor inside our radio already, and you wouldn't need it. But you can put it here in between, and since the operator already has or have this adapter wire, where we have here our special Yaesu connector, so you can use it longer or as long as you want, so no problem, because as you see it is working perfect, and therefore radio can now go back to its owner. I hope you was able to follow, to understand the whole story, and where it is really critical to connect an older power amplifier directly to your radio. But in this special case here, it was definitely something was made wrong during the warranty repair. So from my point of view, during warranty, the whole PCB has been changed out by warranty, and everything would have been fine. Now we try to avoid such an high invoice, because if I do, or if I would have done now exactly the same and swapping out the whole PCB, so that would cost I don't know, 500 bucks, and that is really too much money for repairing this. So yeah, you know, well, no, I think I shouldn't say anything more. So anyway, radio is now back working. Everything is as it should be. You see, the problem was the little diode and not the circuit down here. So that's it for today. Hope you learned something, and catch you next time. Bye.